Okay, so let's see what the problem says. So egg drop. So you are on the roof of a physics building, 46 meters above the ground. Okay, so you are right here. Let's say this is the physics building, and you're here, and you're 46 up above the ground. Okay, your physics professor slash teacher, who is 1.8 meters tall, almost 6 feet, is walking alongside the building at a constant speed of 1.2 meters per second. So everyone, look, let me zoom out. You are here, you are here, you're here, and the prof is not there yet. The prof is somewhere before the building, but they're walking towards the building at what speed? What's the speed? 1.2 meters per second. Okay. The question is, if you wish to drop an egg such that by the time it hits, sorry, by the time it gets to what? To a height of 1.8, it perfectly lands on whose head? The prof's head. Okay. The question is, where should the professor be when you release the egg? So everyone, let's think about this for a second. Okay, pencils down. So let's say you are about to what? About to drop it, and you drop it when the prof is exactly below the egg. Is the egg ever gonna hit the prof? You drop it immediately as the prof is right below. Why wouldn't it hit them? Go ahead, Josh. Unless he stops, then it's gonna hit him. So obviously, do you have to release it before he crosses that threshold, as he crosses, or after? Before. So the question is, where should the professor be? So how far away should he be when you actually what? Release the egg. Okay, can someone, what's the most important thing that we have to solve for here? Speed or time or distance? What do you think? How many people say time? Yes. Why time? Because you have to time it right. Look, everyone, you have to time it such that you release the time it takes for it to reach what height? 1.8. No, well, the height of the prof's head, obviously, it doesn't want to reach the ground. It's the same time that the prof what? Walked and got exactly to where they're supposed to be, right? So the question is now, how do we actually like solve for time for this? Okay, how many objects do we have here in the problem? How many objects that are moving do we have in this problem? Two, the egg and the what? And the professor. Okay, so is the professor walking at an accelerating, decelerating, or a constant speed? So do we need kinematic equations for the prof or just the triangle? Just the triangle. Okay. How about the egg once you release it? What kind of a motion does the egg have once released? Gravity. So what kind of motion? Constant or under free fall? Which means what? Constant motion or acceleration? Acceleration. Okay. Question. How far are you from the ground? How 46 meters. But how far does the egg have to travel? Does it have to travel the 46 meters? No, because it's not landing on the ground. It's landing on what? On the prof's head. So that means what? How much distance does the egg have to actually travel? How would you find that out? How did you figure that out? You took the whole thing and you just minus what? The 1.8. So everyone, let's do the egg side of the equation. All right. So I'll do the egg in green. All right. So for egg, sorry, not G, egg. Okay. Delta D. Oh, should we designate positive to be up or down? What do you think? Should we designate the positive direction of motion for the egg to be upward or downward? How many people say downward? Umayma, why do you say downward? Which is the more correct answer? Exactly. It's moving down, and also acceleration, or sorry, not gravity is also what, pointing which way? By the way, never say acceleration is moving down. Acceleration is what? Pointing down. Acceleration doesn't move. Acceleration what? Points and makes things move in a certain way. Okay, so that means what, everyone? Go here and put the vector this way and put a plus here. Oh, sorry. Above below the. So let's do it here. Go ahead, everyone. Plus. Okay. So delta D equals 46 subtract 1.8, which is how much? 44 point. Is that correct? 44.2. What else do we know about the egg? We know the distance. What else? Hint, it's released. You did not push it down. You just released. So the moment your hand left it, what was the speed? It wasn't moving, or it was about to move, so it started from 0. So VI equals 0 meters per second. What else do we know? Two numbers down, one to go, because kinematic equations always need three. Nura? Acceleration, how much? Positive or negative? For two reasons. First of all, is it slowing down or speeding up? Once you leave, speeding up. Also, is acceleration with what we designated or against? With. So that means, see, two reasons to say it's positive. Okay, so A equals positive 9.8 meters per second squared. And what are we trying to solve for? Final speed of hitting or time of traveling? But are we, okay, does me knowing the speed of hitting the prof's head help me in any way, shape, or form for this problem? No, not with this problem, not with knowing how far the prof should be before. So it's a time problem. All right, so delta T equals what? That. Can we solve now? What do you think? Can we actually commence the solution right now? Perfect. What is missing from the list? What is missing from the list? Final velocity. Which equation doesn't have final velocity? 1, 2, 3, 4, 5. Sigurd. 1, 2, 3, 4, 5. Does not have final velocity. Which one? 3. And what's the good news about your initial velocity? It's what? It's 0. Great. So it's going to be a very easy thing to what? To solve. All right. So let's solve this one. So I'm going to do solution in, yeah, let's stay with the green. Delta D equals VI delta T plus 1/2 A delta T squared. I'm just going to make this comma smaller. All right. What is crossed out? What is gone? What is vanished? Which term? Which term is zeroed out? The VI. Okay, great. So go ahead, everyone, and you can just go like this and put a 0 right here. Okay, so let's write the equation now. What's delta D? 44.2 equals, this is the point, equals nothing, half 9.8 delta T squared. All right, let's what do you call it? Let's solve and simplify. All right, I guess I'm going to have to divide 9.8 by half. Sorry, divide by 2 or multiply by half. Never say divide by half because you're actually multiplying. Yes. Oh, remember, the 0 killed this one. Because remember, okay, we know that 0 multiplying any number is always what? How about multiplying a variable? It's still what? Because a variable is just a number you don't know. And 0 kills any number. So even if you don't know the number, what do you still call it? You still call it what? 0. Yeah. So 0 kills anything, even if you don't know what the variable is. Okay. So 44.2 is equal to 4.9 delta T squared. Perfect. So now I do what? I divide first and then square root. So delta T is the square root of 44.2 slash 4.9 under the square root. Okay, I can figure this one out. 44.2 divided by 4.9 and then square root it. There you go. So apparently the egg is going to take almost exactly how much time to get to the prof's head level? 3 seconds. Obviously, what's the situation? 3 sig figs or 2? Yeah, all of them are 3. So that means 3.00. So 3.00 seconds. Okay, how does that help me with the prof's situation? What do I know about the prof so far? Amar, go ahead. Perfect. So I know that the prof is going at cruise control at what speed? 1.2. And I know that the prof then should have been moving for how many seconds before I released? Do you see what I mean? Everyone, instead of me calculating where the prof is going to be forward, I have to calculate where they were where? Backwards. So basically, I need to know what, like how far the prof was when what? When I released 3 seconds earlier. So basically, I have to release 3 seconds, and I know that it's going to hit the prof right there. Okay, so now we go what? For prof, for prof. Should I call it VI or just V for the professor? Does the professor have a different VI than the VF? What's the professor's speed like? It's constant, so that means what? VI is the same as what? VF. So just call it what? V. When they are the same, just call it V. So V is equal to what was it? 1.2? 1.2 meters per second. Delta T is how much? How much is delta T? The same time that it took the egg to drop. So 3 seconds. So I need to know the distance. Delta D equals. How do you get distance if you have speed and time? What do you just do? Do you divide or multiply? Multiply, because the triangle always looks like this. Triangle always looks like this. Distance on top, which means V here and T here, always. So delta D equals 1.20 times 3.00, which is exactly how much? What does that mean? Everyone, if you want to write a therefore statement, which you don't have to for me, but how would you write a therefore statement here? It's kind of like to reconcile the whole problem together now. Yes, Amar? The students should drop the egg. Uh-huh. Exactly. So if they actually are sharp-sighted to actually see that their marker on the ground, if they mark the point right below them, how much? By what? 0 and 1, 2, 3, 4, 5. They should hit it when they see the prof cross what mark? 3.6. Make sense? When the prof is 3.6 meters away, they should what? They should drop, because they know that how many things. Everyone, look. Everyone, eyes on me. They dropped. Once they drop, how many things are gonna be moving? Two. One is moving this way, and the other one's what? We know that if they timed it perfectly at 3.6 meter distance, what's gonna happen? Are they gonna meet? Yes. What if they release when they were closer than 3.6? What's gonna happen? Exactly. What if they release when they were far away? It will definitely hit in front. Okay, so that's basically the whole idea. Perfect. So let's write a therefore statement really quick. Therefore, therefore, egg egg is released when prof is 3.60 meters away. That's it. Feel free to write, if you don't have space, feel free to write the therefore statement and the white space between the two slides. Okay. All right. Okay. Let's read this one, because I really want to do a projectile most of today. Sam heaves, which throw, 16-pound shot. By the way, does it matter that it's in pounds? By the way, have you noticed something so far in all of the kinematics units? What units have we used so far in kinematics? What units have we used so far in kinematics? Meters, seconds, what else? Come on, we also used like daily street units, like what? Kilometers, hours, centimeters for length. Have we used anything that had to do with? Have we used mass at all? Again, Remember yesterday when we did the projectile motion applet? Did the mass matter? No, because we're always eliminating what effect? Air, air drag. Air drag means what? Mass and the size of the object doesn't what? Or do not what? Matter. So that, by the way, kinematics does not care for the size or the mass of the object. Do you think the rest of the physics does? Yes, when we do forces and energy and momentum and hitting and collisions. Yes, not this one though. So he heaves a 16-pound, which is about 7 kilos, straight up, giving it a constant. Okay, giving it a what? Everyone, he is giving it, or she's giving it, a constant what? Upper acceleration of how much? How much? 35 meters per second squared. Okay, so that's quite the acceleration. Okay, but only for how much distance? For how much? For 60. So about 2 rulers, about this much. Okay. All right. He releases it 2.2 meters above the ground. You may ignore, obviously, air resistance. What is the speed of the shot when Sam releases it? Okay, everyone. Obviously, everyone, look, I'm Sam. Initially, I'm holding the thing. What's the speed so far? And then my hand starts moving up very fast, speeding up, right? What's the acceleration rate? What's the acceleration rate? 35 meters per second squared. And I'm only gonna move my hand up in space by how much distance? 64 centimeters. So do you know 3 things about my hand? Yes, you know that the initial speed was 0. You know that the acceleration rate was 35. And you know that the speed was what? 64. Sorry, the distance was? No, you're right. The distance was 64. And then what happens to my hand? My hand what? My hand stops, which means what happens to the ball? It what? It picks up the energy and keeps going. So my question is, can you now know at what speed the ball was when I? So basically, this is the exact situation. Because the ball is not tethered to my hand. It's not connected. So once I stop, it will keep moving. Make sense? So the question is, what's the final speed? Or what's the launching speed? Question B, how high above the ground does it go? Can I still find that? Okay, but I released it at what level from the ground? Does that have anything to do with the problem? Nope. I just need the distance it travels up, and then I'm going to add it to the what? To the 2. Do you see what I mean? The 2.2 is just an offset. It has nothing to do with the kinematics. C, how much time does he have to get out of its way before it returns? Oh, interesting. To the height of the top of his head, 1.83 meters above the ground. Okay, so let's do this one real quick. All right. Um, so everyone, let's do a quick diagram. Here's the ground. Here's the ball, released at some unknown speed for us now. At what initial height? What's the initial elevation of release? 2.2 meters. We don't know what the initial speed is, but we can, and we know it's gonna what? It's gonna come to a what eventually? To a stop, and then go back, and potentially hit him in the head or on the head. At what height? How tall is he? Or is she? His head. 1.83 meters. By the way, I am not showing the what? Look, everyone. Am I showing the hand phase? No, I'm not. But too much to show here, so we'll just gotta do the calculation for it right there. What's up, Josh? Exactly. We just know that when he released, the ball was at 2.2. Yes, the ball was at 2.2 above the ground, not above his head, not above his shoulder, 2.2 above the ground. Okay, so let's do part A. So part A, I'm going to do it in black as it's more visible. Okay, VI. Oh, I don't know VI, sorry. No, sorry, sorry. We know VI. Yes, it's the hand phase. Yes. VI equals 0. What's the acceleration? By the way, everyone listen up. In the hand phase, does the 9.8 matter? No, because the only force on it is gravity or the hand. Well, technically the gravity is there, but the only acceleration relevant is the what? Is the hand's acceleration. So A equals 35. Wow, that's a huge acceleration. What else do we know? We know that the hand initially was at 0. We know that the acceleration was 35. The distance of just the hand, so delta D is, yep, exactly. Please make sure you switch to standard, 64. And we are calculating VI. Which equation do we know? Oh, sorry, we're calculating VF. My bad. What's missing from the list? What equation does not have time? 1, 2, 3, 4, or 5? Which one does not have 5? The fifth equation. Okay, so let's hey, good news. VF is on the left side, and everything you need is on the right side. And VI is what? VI is what? 0. Yes, Ayad, go ahead. Sorry. Say the. So okay, wait, hold on. So what do you think the final velocity is if we didn't need to ask for it? You're asking. We know that he releases it, right? My question is, if you build up an acceleration of 35 for 64 centimeters of distance, starting from rest, the question is, once it leaves your hand, what speed did it have? Did you see how I remember when I threw this? I'm gonna move, and once I stop my hand, this is not connected to my hand, so it's not gonna stop with it. It's just gonna what? Keep going. So the question is, what's the speed it leaves my hand with? Is it making sense now? Yep. Okay. What's the good news about VI? Come on. 0. So go ahead. Line through 0. Line through 0. Okay. So that means equals 2 times 35 times what? 0.64. How much is that? Well, that is 2 times 35. I know this one. It's 70 times 0.64. 44.8. Is that the speed? No. What needs to be done? Exactly. So it's square rooted. Already squared. So VF equals, now what's the square root of 44? Well, it's between 36 and 49. So it's 6 and some point something. So square root this guy. 6 point, what's the sig big situation? Is it all three? Sure. So it's 6.69. In what? In meters per second. Okay. So the ball is going to leave his hand at a speed of 6.69 meters per second at a height of 2.2 meters offset above the ground. Okay. Hussein, what's part B again? What's part B? Part A is done. Yes, hello? Sure, no problem. B, go ahead. What's Hussein? Okay. How high above the ground does it go? What do I know now, everyone? What do I know about this strip? This strip. I need 3 things. What do I know? Ahmed, just give me one. Just give me one of the 3. You know that the final velocity is how much? No, final velocity of this strip. Of this strip. 0. Someone else give me one more number. Amar, give me one more. The initial velocity is this guy, 6.69. One more number. One more number. وضح. Gravity is plus or minus? Minus because it's what? Because it's speeding down. Sorry, slowing down. Okay. So go ahead, start with those lists as I do attendance, and then I'll join in. Mhm. Yeah, go ahead. I'll just start. Yep. No, no, no. I said VF is 0. Oh, no, no. Everyone, listen up. VI was 0 for the hand phase. VI was 0 for the hand phase. VI is 6.69 for the going up phase. Do you see what I mean? We have a, yes, everyone. We have a hand phase right here. We have a hand phase right here. That's what we just did. 64. Oh, that's how much within the 2.2 that he actually what lifted his hand up by the time he released it. Yes, exactly. He knows that he lifted his hand 64. Look, Jinan. But when he released here, it was 2.2 above the ground. Okay. If if I released from here and 64, that means I will be releasing it at 64 above the ground, right? But apparently he released it at some other level. So when he released it, his hand was at 2.2 meters per.
Because your arm isn't from your
Yeah,
arm
he
isn't
did
reaching
not.
the ground. It's a little here.
Okay. How? Okay. I am 1 point. Uh-huh. Uh-huh. That's it. I'm 1.75. I'm 5'9". When I get to here, maybe I will be slightly above 2, I guess. That's exactly what happened. 64. That's it.
It's not relevant.
Thank you. Yes. The second part has nothing to do with the 64. The second part only has what? This part. That's it. Yes. No, no, no. 2 point. No. 2. No, no. The 2.2 is how high his hand was above the ground. But what he really actually drove it through was only 64 centimeters. Okay, everyone, listen up. Listen up. Just give me 2.2 is not how far the ball. Umayma, 2.2 is not how far the ball traveled. The ball in his hand only traveled 64 centimeters. But when he released it, it happened to be released at 2.2 meters from the ground. You see what I mean? So the 2.2 had nothing to do with the what? With the ball's motion. It just had to do with the ball's what? Release point or release elevation or release height. Okay? All right. So for part B, for part B, what was the final velocity for part B? It stops, so it's VF equals 0. Acceleration is negative because it's slowing down. And VI, at what speed was it launched? 6.69. And we are calculating time of flight or distance of flight. Yeah, because we're interested to know just how high it actually traveled up, I think. How high above the ground does it go? Yes. So delta D. So what's missing from this list? So which equation again? The fifth equation. But now we kind of have to solve, okay? Because delta D is on the other right side. All right. Uh, VF squared 0 squared equals 6.69 squared plus 2 negative 9.8 delta D. Bless you. By the way, now, do I need to square 6.69 or do I have the number already in the first step? Perfect. Because remember, if you square 6.69, it's an approximate. You're not going to get exactly what? 44.8. But you do realize that 6.69 came from this guy. So 0 equals 44.8 plus times the minus is minus 19.6 delta D, which means delta D is this. Obviously, you're going to have to move and divide. So delta D is 44.8 divided by 19.6. 2.29. Now here's the question. Is this the distance above the ground that it stopped at, or is it just the distance that it traveled in the air? The distance that traveled in the air. We still need to account for what? The 2.2 what offset ground release. You see? Again, everyone listen up. If you're feeling overwhelmed with how these problems are either done or presented, that's fine. Those problems are what kind of problems? University problems. You will see all of these perfectly, literally the same ones next year. So feel okay that you're at least seeing them now. It's a good thing that you get time to actually practice them now. So we can say what? Height above ground equals how much? 2.2 plus what? 2.29 equaling, well, 2.2 plus 2.3. Oh, what am I saying? 4.49 meters. Yeah, go ahead. Yes. Yeah. How do I what? Oh, so up to here is good. Okay. So 0 squared is 0. 6.69 perfectly squared will give you back 44.8. Plus times the minus is minus. 2 times 9.8 is 19.6, and the delta D. And then I quickly, without showing, moved this guy here, and then divided this guy by the 19.6 when it moved there. Okay. Okay, I need someone to read part C. Amar. Okay, everyone, listen carefully to part C and try to imagine it in your head. Go. So everyone, how much, basically, they're saying, how much time is it going to take from the moment he releases it until the moment it comes back to what height above the ground? 1.83. Okay? Okay. Everyone pencils down. What did we do yesterday? What topic did we do yesterday? Projectile motion. Is this a projectile? Everyone, I'm going to show you a very good shortcut for these problems. Is this problem a projectile? But how? We said that a projectile has to have a what? Has to be thrown, you know, anywhere. Then how come this is a projectile as well? This is a special kind of projectile. It's just that your angle made it all the way up to what? Is it making sense now? So remember, everyone, a projectile still applies to what? To what? To 90 degrees going up. Okay. So now let's think about this for a second. Everyone, what was the, so we need the what? The time of flight, right? We need the time of flight. Okay. Everyone, at what height did it start from? Not how much distance did he travel with his hand. No. What height did it travel from? 2.2. Okay, everyone, look at my hand. Everyone, guys, go up, go up, go up, go up, go up. Come back to the 2.2. But then it actually needs to go lower to what level? 1.83. So overall, we are just interested that it was displaced from where to where? From here to where? Is it making sense? I really could care about what? Look, everyone. By the way, the hard way to do this problem is to divide it into how many trips? An upward trip and a what? And a downward trip. The easy way to do it with projectile motion is just to say, you know what? I know it went up and down, but I'm just going to care that it started here and ended where? And ended here. So can someone tell me how much distance is the difference between 2.2 and 1.83? What do you just do? Do you add or subtract? Okay, so good. Don't do anything. So we got that number down. Second thing, if it's going this way, if it's going this way, and we said, what? We put the positive direction for projectile motion which way? Up. If you go down, then what's the displacement direction? Positive or negative? Negative. Also, acceleration by default is always pointing which way? Down, which is also what? Negative. I can use what? One of the equations for the delta dx or the delta dy. By the way, do we need to use the equation for delta dx? Did it move sideways? Did it move up and down? Yes. So we're going to combine projectile motion now. All right. So everyone, let's write using projectile motion. Yes, go ahead. Okay. Delta dy equals vi. Everyone, vix or viy? Yeah, you can't mix y and x. You start with y, you have to end with y. No, go, please. I love nothing more than when people teach each other. Yes. But no, Kadir, I want her to keep explaining, but just focus with me on this one. Okay. Do you remember what VIY was equal to? I gave you an equation for VIY and VIX. Remember trigonometry. One of them was something, the other one was the other twin. Come on. One of them was sine, one of them was cosine. Do you remember which one was the VIY? It was the sine. By the way, sine is always the y in physics, and x is always the what? Especially, not always, but especially when you're given the horizontal angle, which is always going to be the case. All right, so I want you to what? Circle this guy. Sorry. Circle this guy. And write what? VI sine sine theta for now. You're right. You're right. It's going to come up to 90. Okay, let's put numbers now. Delta dy, is it positive or negative? Did it, again, I know it moved up and down, but overall, it moved what? It moved down because we wanted to have, it's like, okay, everyone, look. Someone released it. Sam released it. You only looked when they released. And then when it got to this, you look back. All you've seen is that it went from this height to what? To this height. You see, you know it went up and down, but you can't say for sure, right? Remember, displacement is passive observation. You did not look, so you assume, oh, I'm gonna assume it went straight down. Okay, so everyone, negative what? Okay, what's the difference between 2.2 and 1.83? 17 plus 20, yes, 37. So negative, everyone, negative point. Oh, sorry, I can't see the boundaries of the page. Negative 0.37. What was the initial speed of launch? That's VI. No, initial speed of launch.
Oh,
Initial speed of launch. What was the speed it left his hand? 6.69. VF of the hand phase, VI for the you see, by the way, you see how those problems are confusing because they connect one stage to the other? That's the main thing you have to understand about these things. Okay, sine of what, Ahmed? Sine of 90 degrees. Which is what? Which is 1. I told you, when you are 90 or 0, one of them is 0, one of them is 1. Sine of 90. Yes, cosine of 90 is 0. You can't have both of them zeros. You can't have both of them 1. Yes. No. It's going down as an eventual displacement. But the initial speed of the release was going what? Was going up. So it is positive 6.69. In fact, you know what? Good thing that Ahmed reminded me. Everyone put positive here to emphasize to you that it is positive speed up. Minus. Oh, what am I forgetting? Okay, good. Yes, it has to sink in. Okay. Do you think we're going to have to do the quadratic? What do you think, everyone? How many people say no? Sadly, it's a yes. You know why? Because sine, no. You know what? You're not going to have to do it if the sine 90 is 0. Because then it kills this part and then just becomes a two-term thing. Sadly, sine 90 is not 0. It's what? So it is going to fully survive, which means you have to do quadratic for this one. Okay, no problem. Negative 0.37 equals, this is 1. So just 6.69 delta t minus 4.9 delta t squared. Okay, No more physics. How do you solve the math for this one? Yeah, but what do you have to do first?
Oh, you have to.
Aha. Remember, you have to move everything to what? To one side, preferably the what? The left side, where your minus here becomes what? Yeah, by the way, always you want your quadratic coefficient to be positive or negative. You want it to be positive. Yes. Go ahead. What's up? Oh, I'm gonna move everything.
No, because if you use negative 4.
I know, but that means I'm gonna start my quadratic with a negative. You see, my A value would be negative, my B value would be positive, and my C value would be positive too. Oh, would I ever say no to that? No. Remember, I never tell you that something is wrong if it's correct. But I'm just telling you what, when you plug in, would you rather plug in positive or negative numbers for the quadratic coefficient? That's it. That's all there is to it, honestly. So 4.9 delta t squared minus 6.69 delta t minus 0.37 equals 0. Okay, how can we? Who's got a calculator that could do quadratic? Anyone? Probably gotta be double display. You have it? Okay, perfect. Everyone, I'm gonna use Candace just to get the delta t values. Okay. So A is what? 4.9. B is what? What's B? Negative. Yes. The biggest mistake is people do not put the negative. Negative 6.69. What's C? Also negative. Negative 0.37. All right. I got 2 times. One of them was negative. Is that good news for me? No, actually, it is. Because I'm not going to take the negative value. That's what I meant. Exactly. Everyone, I don't want to say it only gets confusing. Can time ever be negative? That's my point. I got a negative value, which basically tells me you only have one correct physically admissible answer. That's what I'm talking about. Do you see what I mean? Thank you. It makes the answer obvious. Can time ever be negative? So could it ever be this value? Oh, I just go for the other value. Because remember, a quadratic always returns how many values? 2. If one of them is negative, that doesn't make sense physically. That's it. That's the answer. Right there, done. Because that's the other answer. Oh, no. It did the quadratic formula in its memory. It did the quadratic formula and it got 2 answers. One of them was what? It did it. I just used basically the function in it to actually do it. But the good news is it gave me a negative time. Remember when we did it 3 days ago and we got 2 positive times and we had to decide which one was the correct physical one? Well, guess what? Can time ever go backward? That's the meaning of a negative time. So what's the answer? 1.42. Everyone? Delta t is 1.42. Delta t is 1.42 seconds. Oh, sorry. Say again? No. Okay. Jinan, when we solve any quadratic equation, we really end up solving for both. So delta t, okay, what I'm saying is if you plug in 1.42 here and here, you're going to get what? 0 if you plug it in. That's the meaning of the quadratic equation. Plug it in and it will zero out itself. Okay? So apparently he has 1.42 seconds to do what? Because it was only thrown straight up. By the way, this last part is not an easy problem. And I guarantee you at least 30 to 40% of university students would either get it wrong somehow or somehow would not even be able to really start it well. So it's okay. You're getting to see something almost a year before you start. Okay, let's do one projectile. I need something with an angle. I need something with an angle. This. I tend to see this in a lot of quizzes and midterms in first year. Everyone, 355. Yeah. Yeah. By the way, hopefully by the end of this course, we'll spend a day where I will actually get my personal hard drive and actually open up actual exams from Western And you will see that not a single problem I do with you does not make its way to the midterms and quizzes. Yeah, I know what you're going to see next year. Why would I not show it to you now? At minimum risk. All right, an airplane is flying with a velocity of what? Or speed of what? 90 meters per second. At what elevation angle? So everyone, like this, look. The plane is moving this way, 23 from the ground level. Okay, above the horizontal. When the plane is 140 meters above a what? Above the ground, basically. Above the ground, that is standing on level ground. A suitcase, what? Drops out of the luggage compartment. The question is, how far does the suitcase land? Okay, everyone, check. Yeah, everyone, check this out. Eyes on me. Eyes on me. Ali, eyes on me, because this will actually relate to this problem, even though it's an easier way. Okay, Josh, watch this. If I release this lead, whatever, lead pencil case, or if I release it, what's going to happen to it? Where is it exactly going to drop? Directly below my what? My hand. That makes sense, right? Okay. How about now? How about if I drop it right when I get to Waddah? Is it just going to drop down? Okay. So you know what? Fine. If I released it while I get to Waddah, while I'm still walking, is it just going to drop down? Well, let's see. Okay, this is easier to drop. Did it perfectly drop here? What happened to it? Did it move forward a little bit? What if I was moving faster? It would drop again, same distance or further even. What does that mean? If you drop something while walking, does it just drop straight down or does it go through a curved motion? Projectile. That's the key. So basically, so imagine this. If I slow down like if someone actually takes a video and slows it down, they're going to see that it did not drop straight down. It dropped both down, but it was still moving what? Moving what? Because initially, when it got released, it was moving which way? It was stuck to my hand, and my hand was moving what? Forward. So when it got released, it still had some what motion in it. But then what took over? What force? So that means what? It still kept the forward motion, but then it starts moving what? So how is it going to end up? Right down or forward a little bit? There you go. You got it now. So, okay, everyone, think about it this way. The moment of release obeys the initial motion. And then it just goes what? Just goes what? Goes down. Okay. So let's sketch a quick diagram here. How is the plane moving initially? Level or above? Above. Okay. So here is the, okay, actually, here's the ground. Okay. So I know that the release was, okay, so everyone, here's the plane. Just sketch a, like a tube with wings. Plane. All right. Okay. What's the speed going this way? What's the speed? 90 what? Okay, meters per second. Okay, I thought it was kilometers per hour. Good. 90 meters per second. What's the angle here? 23 degrees. What's the distance right here above the dog? 114 meters. So everyone, the moment the luggage or the suitcase gets released, how is it moving? Is it moving still with the plane? The moment it gets released. Yes, it was still moving up at 23 with what speed? Everyone, the suitcase was stuck to the plane, right? So as far as you're concerned, also the suitcase was moving at what speed? At what angle? And it was launched from what height? Great. So do you think it's going to go? Okay. Does it make sense to drop down straight? Does it make sense to drop just this? Or is it going to move up and then down? Because it has to trace the initial motion. You got it. So basically, That's dead mouse, okay? With big ears. All right. What shape did I sketch? What shape did I sketch? A parabola. Okay? Yes. No. Okay. Did they give me any size information about the dog? Done. That's it. Although they could. Sure. Above it, which means the dog is still within what? The ground level. Okay. Can someone tell me what was the first equation of projectile? Come on, people. I know you're getting overwhelmed, but this is the last one we're gonna do it for today. What was the first equation for projectile? Was it the delta dy or the delta dx? Okay, everyone, let's write it down. Okay, don't write it down with me. I'll tell you why. Is that the equation in an expanded form? Yes. Tell me what I know about this equation. Do I know delta dx? By the way, where is delta dx? Delta dx is from here to where? To the landing point. Do I know it? No, I'm trying to find it. Okay, so I don't know that. So everyone, I'm going to put a question mark here. Do I know the initial speed of launch? I know that. Do I know the initial angle of launch? Do I know the time of flight? So can you ever solve a single equation with two unknowns? Not even the, okay. Again, remember the example. Give me two numbers that add up to 10. There's an infinite number of answers, right? Right? 1 plus 9. And if you go to negatives, and if you go to decimals, and if you go to real numbers, you're expanding your what? Your choices. So you can never solve a single equation, sorry, like in two unknowns, with only with only one equation. You need two equations and two unknowns. Remember grade 10, solving by elimination and substitution? That's the whole idea. Okay, so I can't use this equation. Do you think it's worth trying the other equation? I'll give you a hint. Remember the sine and cosine law? But remember the sine and cosine law? If the sine law doesn't work, what has to work? And if the cosine law doesn't work, what has to work? One of them has to work. Okay? So everyone, let's actually start with the second equation. Oh, you don't have to write it because it's not going to work. We're going to start with what? It's in the video, don't worry. Delta dy equals vi sine theta delta t minus what? Delta t. Do I know how much the suitcase dropped? Remember, I don't care how much it moved up and down then. I just care how much it dropped from the moment it got released. 114. Did it drop up or drop down? Nothing drops up. It drops down. So what kind of a 114 is it? You got it. So everyone, oops, negative. Okay. What's the initial speed? Was it pointing up or pointing down? Up. Yes. What's the sine? What's the angle? Why is what negative? Because okay, eventually, did it end up with a positive displacement or a negative displacement? It dropped to the ground. So anything that drops to the ground means it started above the ground, which means it went what? There you go. That's it. Everyone, physics is done. Math takes over. Let's clean up. Can someone get me 90 times sine 23? So I'm just going to write it. What's this guy? Come on. 90 times sine 23. 35.1, I would say 7. What needs to move to the other side? What needs to move to the other side? Yeah? Everything else. So 4.9 delta t squared minus 35. Okay, Kenda, you ready with your machine? Okay, so Kenda's gonna use A for 4.9 for A, B as negative 35.17, and C as negative 114. Everyone, let's see what Kenda gives us. What kind of answers do we get? Okay, wait a minute. How much? What's 9.60 or negative what? 4? Everyone, which one doesn't make sense? For time. Done. Cross it out. Physically inadmissible. See, math never cares about the physics, right? Math always gives you, everyone listen up. Math gives you what? The two intercepts if there was an actual parabola. It doesn't care if it makes sense or not. It gives you the diagram. You as a physics person, you have to take both of them and say, one of them can never happen in real life, which is negative 2.42. Now what equation can I use? The what? The short equation, right? Delta dx, because I just found out what delta t is. So last thing is delta dx equals vi delta cosine theta delta t, which is how much? 90, 90, yeah, 90. Cosine of 23 times what? 9.60 seconds of flight. All right, I'll do the cosine of 23 first. And then I'll multiply by 90. And then I'll multiply by 9.6. How far from the dog would it drop? Or how far does the dog have to run to get it? 795. We're doing 3 sig figs, so that is up to there. 795.3, which is 795. Everyone, right? From what? From the dog. It's not easy, but with continuous practice, it sinks in. It's a good thing we're practicing already with harder stuff, so you don't waste your time with just grade 12 stuff. You're already seeing things